So studies show that if you think about what's on the test before the test, you do better on the test. I'm okay with that. So what I'd like you to do is just flip through your review packet and go ahead and on the little half sheet, write down what you see you're going to need to know for the test. What are the things that you want to make sure that you remember? And take some time to chit chat with your partner about this too. All right, so have your review packet out, and I want everybody on the same page as me, so we're thinking about it, and I want you to make use of the colored pencils that you have and the highlighters in your basket. The first thing I want you to think about is all of these words here have to do with inductive reasoning. So glance your eyes over those and think about if you could tell somebody a story about them. If you could put those three words in a sentence together. Inductive reasoning is maybe when you're looking for a pattern, you make a conjecture about what that pattern is, and you really don't know the truth value until whether somebody can or cannot find out a counterexample. In order to organize and represent those inductive reasoning conjectures, we come up with the idea of conditional statements, if then. And we can test it to help us find those truth values better. Think about the relationship between the implication and the contrapositive. They're linked. My inverse and converse, they're linked. A different kind of statement is a compound statement, and that's where we talked about the idea of conjunction and disjunction. We ended up spending a lot of times talking about Venn diagrams and what they ended up looking like. Our simple and compound statements have those overlapping Venn diagrams. Our conditional statements have those nested Venn diagrams. So we can think about the difference between what those types of questions are asking. When we moved into talking about deductive reasoning, that's where we ended up saying, thank you, Euclid, for simplifying things. It's not up to me to find the pattern. It's not up to me to make a guess. It's not up to me to have to find a counterexample. Instead, my law of detachment guarantees that if I'm given a factual statement and my hypothesis happens, I can be guaranteed that that conclusion will also happen. So that's that law of detachment. My law of syllogism is the one that allows me to bring a third conversation in and kind of link all those statements together. We practiced a lot of these biconditional conversations when we talked about all of these definitions. And these are all Unit 1 conversations, so they are fair game. Do you know the difference between midpoint, parallel, perpendicular, congruent, angles and segments, complementary, supplementary? And then we played with these properties of real numbers, commutative, associative, and distributive properties. And then we went ahead and talked about our algebraic properties of equality and what they were. And we reminded ourselves of some of our postulates that we end up using, segment addition, angle addition, to justify what we're doing. Any terms that you look at as we break them down that you're like, can we go over this one more time? I don't get it. Which one? Okay, so your transitive property is, it feels like the law of syllogism. But your transitive property is the one that lets you say, let's say that I have the distance from A to B is equal to the distance from C to D. And then you find out that the distance from C to D is the same as the distance from E to F. Because that one thing is in the conclusion and the hypothesis, we can go ahead and say that the distance from A to B is equal to the distance from E to F. That transitive property allows us to link those three ideas into one statement. Does that help? That's the transitive property of equality. If I'm talking about congruence, then I'm talking about segments that are congruent, segments that are congruent, therefore segments are congruent. So that transitive property, if I'm dealing with numerical values, it's equality. If I'm dealing with things, segments and angles, then it's congruence. Does that help? Okay. All right, this first part, oh dear, I need to make sure. I thought I had pulled up the key. Give me just 1 minute and I'll pull up the key. Here we go. All right, so here is our key for this. If you're given the statement, doing homework helps students learn. When we go to write it as an implication, we need to have an if involved. If students do the homework, then they learn. And then, of course, our converse, inverse, and contrapositive. Now, if we wanted to, we could argue about whether we think that this is a biconditional statement. Teachers would love to answer yes. I would love it to be a biconditional statement. The only way you're going to learn is if you do your homework. You will learn if and only if you do your homework. Because I want everybody doing their homework. But there's other times that you learn, whether it's learning in class or learning from doing notes and activities, learning talking to your friends, however it is that helps you learn. Conditional statement. If it is warm, then we'll go out swimming. This one's very straightforward. If it's warm out, then we'll swim. Not warm, not swim. Go swimming, that's warm out. Not swim, not warm. This next one is a little bit more interesting because my if and my hypothesis is in the second half. So when I do my implication, it's if you're on the tennis team, then you like to play tennis. And my inverse, converse, and contrapositive go from that P and Q. Make sure you look for the if. I will go to the homecoming parade. Is my P. My Q is I will not go to the football game. So when I have a negation of a statement that is in a negative state, then I end up deleting that because I'm negating it. So it sounds like I will go to the football game or I will go, or go to the homecoming parade or go to the football game. When I have parentheses, we know to dive in and do this first, looking at evaluating P and Q, and then that negation is going to take the opposite of what the outcome of P and Q was. Now, when we go to speak, we naturally add either a comma or a semicolon in to give that pause so that you know that those two values are joined. I will not go to the homecoming parade and not go to the football game. So you will not have those combinations of things. It's confusing when you write it, which is why the truth table helps us out. Because here we have the conversation for P and Q. That's going to be true when both P and Q are true. When we go for looking at not P and Q, this ends up just being the negation of my first column. If this was true, now it's false. If this was false, now it's true, and so on down. Does that make sense? Okay. Next page. Here it is with syllogism. And it's funny, the syllogism feels like transitive, but syllogism is a law of logic using ideas, and transitive is a property using either numeric values or things. So if it's raining hard, then the basement's flooding. If the basement's flooding, then I will call my landlord. So I can just connect to them. If it's raining, I'm calling my landlord.
On the test, will there be a second
No. No conditional true statements. If it's cold out, I will go skiing. I don't know. It can be cold. It's cold out lots of days that I don't go skiing. If you make the varsity football team, then you're playing the games. Nah, not always. You can stand on the sidelines. Examples of each of those properties. Let me know which ones you need support with or help with. Go ahead. Yeah, my reflexive property looks different in geometry than in algebra. If it's the algebraic reflexive property, that's just A is equal to A. If we're talking about geometry, I've got two conversations, equality versus congruence. Here I'm talking about the distance from A to B. So if I have a line segment AB, I'm saying that I don't care which way that you measure it from A to B or B to A, it's going to be the same. So that's going to be that distance from A to B is the distance from B to A. That's different from our symmetric property because our symmetric property brings in something else. Our symmetric property in algebra is the one that said if your x ends up on the right-hand side and that freaks you out, go ahead, spin it around and call it x is equal to 3. So we can do the same thing here when we're talking about two segments that either are congruent or equal through the symmetric property of equality. Remember, if it's congruence, it's things, and that involves either angles and segments and the congruent symbol. If it's equality, that's a numeric representation. Sound okay? Down here, remember these symbols mean those are congruent, so I can set them equal to each other and solve. By angle addition postulate says if this whole big thing is worth 4x minus 10, then the sum of those little two parts will make the whole. Are we good? For this one, just looking at linear pairs, vertical angles, complementary, supplementary angles, opposite rays, adjacent angles, congruent angles, making sure you understand what each of those vocabulary terms are. Anybody have a question about those? Okay. Say it one more time. So a linear pair is going to be two angles. Linear pair is going to be two angles that are congruent and supplementary. So do you see how I have this angle? Like that? Not congruent, supplementary. Adjacent and supplementary. So having them both share this common side makes them adjacent, and having them have opposite rays makes them supplementary. So any two angles that are adjacent and supplementary. Go ahead, Anna.
How does the angle SBD and
FBD. Let's see what she's talking about. FBD, go ahead.
and angle DBC?
Yeah, that's good. That's fine. Adjacent and supplementary. All right, vertical angles are equal, so I can set these two expressions equal to each other and solve. Linear pairs are adjacent and supplementary, so I can set them equal to 180 and solve. Questions there? Here, because in the diagram, I know that this segment is congruent to this segment, I can go ahead and set them equal to each other and then solve for x. Once I solve for x, I could take that value and substitute it in and get these values for those two segments. And then I can go ahead and find that distance from X to Z. And I know that's the segment addition that allows me to add them together. My definition of congruence allows me to set them equal to each other. And my substitution property of equality allows me to put that value for X into the expression and then simplify. Go ahead. Yeah, so what's interesting here is it asks for the length of XZ. So the length of XZ is going to be equal to, what's that, 26? 26, and that is the segment addition postulate. Finding X was a matter of congruence and subcode. Does that make sense, Fred? Solve the equation and give a reason for each step. We're going to use the distributive property, combining like terms, and then the subtraction property of equality to solve. Make sure you know the distributive property versus the division property of equality. Since I'm sharing this 3 out to each term, it's definitely this one. My division property of equality is only when I'm dividing both sides by a value. Sound okay? Questions on the algebra? Preston, are you with us? All right, so state whether the valid is, the argument is valid or invalid. I don't like how this P and Q are listed, so I'm going to change it. If it's a rectangle, then it has 4 sides. That's my P and my Q. Then I'm told that my figure is a rectangle, so I'm told that P is true. So once I know that P is true, I know then that Q is also going to be true. That's valid because of the law of detachment. If you're a student, you have lots of homework. If you have lots of homework, then you will not get enough sleep. This lots of homework is in the conclusion and hypothesis. So what I can do is go ahead and know if I'm a student, then I'm not going to get enough sleep. That's going to be a valid argument for the law syllogism. If you miss 0 days of school, that's my P. Then I will get a good grade in the class. That's my Q. Hey, congratulations, you got an A. But that doesn't necessarily mean that you were here every day. Maybe you went on Schoology and watched the class videos. Maybe you came after school to make up what you missed. There's lots of ways you could get a good grade, even if you're absent. All right, our Venn diagrams. In a survey of what type of fast food people like, 15 people like Chick-fil-A. 6 people said McDonald's and 3 people said they liked both. So when I go to fill out this diagram, I put my 15 people liking chicken. I put my 6 people liking McDonald's. But as soon as I put my 3 people that like both, in my circle now I have 18 people. That's 3 too many. Because these 3 were double counted in both surveys. So I have to cross off that 15 and recognize that 12 that just like Chick-fil-A plus the 3 that voted twice represent my 15 people. I need to make that same change over here because now the 6 people that like McDonald's are evenly split between the 3 people that like them both and 3 people that just like McDonald's. When you're asked to write a statement showing a conjunction, whether you have the numbers in it or not, I don't care. This is a diagram of the people that like Chick-fil-A and McDonald's. When I look at how many people are in my diagram, 12 plus 6 is 18, and they tell me they talked to 20 people. I'm like, okay, well, what happened to the other two? They're here, people I talked to, but didn't like either one. So we like to play with what kind of information we give you. 22 math teachers surveyed about their favorite types of pie. 13 like apple, 11 like pumpkin, and 2 teachers like neither. Once I put these 2 teachers out here, I've got my 13, I've got my 11, but once they tell me that they talked to 22 people, when I add 13, 11, and 2 up, I get 26. So I've got 4 extra votes. I only talked to 22 people. Why do I have 26 answers? Do you see how that doesn't make sense? Because I had 4 people pick both. So if this circle represents 13 people, right now I have 17. So I have to rewrite that to make sure that my numbers add up and make sense. Only 11 people voted for pumpkin. The way that I have it written now, it's 15. So that 11 has to be balanced out for the 4 people that voted for both. Make sense? Any questions on the review? Something I can help you with? Explain further? Are we good? All righty.